All right, we're getting back to our discussion about stretches and shrinks. So we said we want to talk about direction, factor, and then whether it's a shrink or a stretch. And I introduced this concept of B, the B value, which is really in the book as an A value, but it's inside these parentheses. And then we talked about direction first. We said when A, absolute value of A or B is greater than 1, then that graph is going to move towards the y-axis. And when it's less than 1, it's going to move away from the y-axis or get narrower. We said that these parentheses are important. And now I'm going to talk to you about factors. So stretches and shrinks towards the x or y-axis by a factor of. So when we consider the A value, it's going to be a factor of that A value, but the B value, a horizontal stretch or shrink, is a factor of 1 over B. Right? So the A value, factor of A. With a B value, it stretches or shrinks by a factor of 1 over B. All right? So there's a difference between evaluating or talking about the factors of stretches and shrinks. All right. So then let's go through some classwork problems and talk about factors of. And we're going to go back to the list of quadratic functions that we were referring to, and we were talking about whether or not it was a vertical or horizontal stretch, and whether it was towards or away from the y-axis based on the value. And so now we want to add that factor. So I want you to work along with me here. You're going to attempt to do this on your own. I'm going to give you the answers, and then I'm going to give you classwork problems to do. All right, so please see if you can add the factor to this, and you can pause. I'm going to give you the answer. Okay, so I have a horizontal factor with horizontal stretch with a factor of 1 over 2, so 1 over B. This is A by itself, so a vertical stretch by a factor of 1/2. Horizontal stretch by a factor of 1 over 1/2, which is 2. And then a vertical stretch by a factor of 0.75. All right, last thing we want to talk about is stretches or shrinks. And so there's a vertical stretch or shrink. If A is greater than 1, then it's a stretch towards the y-axis. When A is between 0 and 1, then it's a shrink away from the y-axis. For the B value, when B is greater than 1, it's a shrink towards the y-axis. So the direction is going to be towards the y-axis, but we're shrinking. And then when it's between 0 and 1, it's stretching away from the y-axis. Okay, so these are you should use this as a cheat sheet in addition to the other slides as you continue to work on this. So let's go back, I think, to the list that we had before. So now we want to determine if it's a shrink or a stretch. So please work along with me on this. And take a moment. And I'll come back in a moment. Okay, so for the first one, I'm going to shrink by a factor of 1/2. I'm shrinking towards the y-axis. Then I have a vertical shrink by a factor of 1/2. I'm shrinking away from the y-axis. Next one is a horizontal stretch by a factor of 2. I am stretching away from the y-axis. And then finally, vertical shrink. I am shrinking away from the y-axis by a factor of 0.75. All right, so that brings us to our next set of classwork problems, 2.1.3. And I'm going to have you copy this down. So you need to determine the type of stretch or shrink, horizontal or vertical, the direction in relation to the y-axis. Your book does y and x, and I'm just asking you to do for y. Because that's the information I've given you. The factor, and then whether it's a stretch or a shrink. So this is your classwork. This again is your third set of classwork, you can take a moment, pause here if you can, and copy this down, and then I'm going to move on. Okay, last thing we need to do is to write transformations of quadratic functions. And let's go through that. All right, so we're going to say let the graph of G be vertical stretch by a factor of 2 and a reflection in the x-axis, say over the x-axis, followed by a translation of 3 units down of the function f of x is equal to x squared. All right, so this is how we're going to do it. We're going to do it in order as I've given it to you. So let G be a, hopefully we got this right, vertical stretch by a factor of 2 and a reflection over the x-axis, followed by a translation of 3 units down. Okay, so we're going to break this up into the 3 pieces, and I'm going to do this in order. And you need to do it in order because if you're given a different order, you might end up with a different equation. So you're going to compose the transformations in order using this formula here. I have G be a vertical stretch by a factor of 2. Right, so I have my basic formula. So vertical stretch by a factor of 2, so A becomes 2. And then a reflection in the y over the x-axis. Now this becomes negative 2, followed by a translation 3 units down, so negative 3 here for K, and that's it. So there's no horizontal shift, so then this value becomes 0. Right, so we end up with y is equal to negative 2 x squared minus 3. And then if we were to graph that, right, I start with y, and you got to follow along here. Y is equal to x squared is blue. Okay, now I'm going to stretch by a factor of 2. So this black here is stretching towards the y-axis. And by the way, as you do these, great to follow along in Desmos. All right, and then I'm going to reflect by making this a negative 2. So I've reflected this black line. It becomes this red line. And then I'm going to shift it down by 3. And I end up finally with this quadratic function. Okay, pretty cool. All right, so let's go through, I think, another one for you, and then I'm going to have some classwork. Let G be a horizontal stretch by a factor of 2, a translation 3 units up and 2 units down, and a reflection across the y-axis of the function. Remember, you're going to do these in order. Okay, so here I have my setup. G of x, it's horizontal stretch by a factor of 2. Whoops, so now I have to change this. All right, so I just changed this to reflect. I changed the horizontal stretch from 2 to 0.5. Sorry about that, just to reflect what I did with the graphs. So, okay, so I'm going to do a horizontal stretch by a factor of 0.5, translation 3 units to the left and 2 units down, and then a reflection across the y-axis, the function f of x equal to x squared. All right, so I have my setup here. 1 over b is going to be my 1 over b is going to be my factor. So 1 over 0.5, I'm sorry, 1 over 2 is going to be 0.5. So my factor is 1 over b, b is 2, 1 over 2 is equal to 0.5. And then I'm going to translate it 3 units to the left and 2 units down. So 3 units to the left makes this positive 3, and 2 units down would be a negative 2. And then I'm going to reflect across the y-axis. So this x value, not the 2, not the b value, but the x value then becomes negative. And since, oh, that's not true. I have a horizontal shift here. This is copied from the last one. Sorry about the errors here. You're going to end up with y is equal to 2 in parentheses times negative. And remember, this has to be in parentheses because you're squaring it. Right, this 2 can't be outside the a value because that value is not squared. So inside the parentheses 2 times negative x plus 3 squared minus 3. All right, moving on. Okay, so this is what it looks like here. I have, it looks like I kind of messed this up because this should be 1/2. Never mind, I got this right. All right, so I have y is equal to x squared here. It's the black line. And then I'm gonna I'm gonna stretch. I'm gonna shrink this is a horizontal shrink away or towards the y-axis and away from the x-axis. So here's my horizontal shrink by a factor of 1/2. And then I'm going to shift this graph 3 to the left and 2 down. So this is the next step. And then finally, I'm going to reflect it over the y-axis by changing this value to a negative x. So you can see the sequence: parent function, the horizontal shrink, then the translation, and then the reflection. All right, so this is composition of functions. All right, so I'm going to give you your next classwork problem. This is 2.1.4. I'm going to have you let G be let the graph of G be a horizontal stretch, and this is of the parent function by a factor of 2. Translation 3 units to the left, followed by a reflection in the x-axis or over the x-axis. All right, so you can copy this down, and I believe that that is it for today. Thanks for joining me, and you're going to come back next time, and we are going to talk about characteristics of quadratic functions in lesson 2.2.